We have a software called RISA Connection. This RISA Connection, you can download a demo version like RISA 2D or RISA Floor or something like this. So we have a product called RISA Connection. This product only for connection between steel members. I will start from scratch. Let me start first. If you set up your software, you will find a small icon called RISA Connection. Double click demo version, because I don't have a license, and agree. You have 3 options: recent project that you were working on, or open any old project or new project. You can define what is the name of the company, what is the name of designer, what is the title of the project, what is the job number, any notes do you like to include in this project. Then, okay, we have many connections. But before starting, I would like to explain something. Guys, sometimes you find or you found in structural analysis course, beam looks like this. We have here roller, we have here roller, we have here hinge, and at this position we have a connection. In structural analysis, we called this connection looks like pin connection. So sometimes we call it A, B, C, and this connection can be called pin connection. This pin connection has value for shear, and the value for moment equals 0. We don't have moment at this connection because it's called pin. If you have pin, we don't have moment. So this pin connection between this member and this member, this pin connection can transfer shear only, cannot transfer any moment. Let me explain it in more details. If we assume this part of the beam looks like W shape, like this. That makes sense? The other part of the beam looks like this, W shape. How can I connect between how can I create a connection between this part of the beam and this part of the beam to create this pin connection? Okay, regardless what is the name, what do you need? What internal forces do you need to transfer? We need to transfer only shear. We have a value of shear here, but the value of moment is 0. If you would like to do this, okay, for your connection, we have here shear transfer connection only. We have another connection here called moment, if you would like to transfer moment beside shear. But right now, we are in a case of a beam at a connection called pin connection. This connection only transferring shear without moment. So if you open your software, we will select something called shear only. What is the type of your connection? Is it between beam and the column? Do you think this connection between beam and the column? No, it's between two beams, beam and beam. So I will not use beam column. Is it between beam and the girder? Beam and the girder means you have a girder and you have another beam, and this beam is supported by this girder. So we need to simulate this connection. I think this is not the case. I think your case is beam splice. Beam splice. It's only one beam. This is one beam. But at this connection, we have a splice between two parts of the same beam. So I'm trying to explain what's going on in these selections. Shear means a connection will transfer shear only without moment. What is the connection? Is it connection between beam and the column? Is it the connection between beam and another girder? Or beam splice? I think it's a beam splice. If you open it and choose this connection, okay, you will see something like this. Keep in your mind, guys, I'm teaching not the software RISA connection. I'm trying to give you some concepts, few concepts. If you would like to connect between this beam and this beam with a connection to support shear only, you need to connect this web by this web only. Web connection only. These two webs by connection. That's all. If you would like to create a connection between beam and another beam, the same beam but two parts, and this connection to transfer shear only, which is the case of pin connection, you need to connect the two beams by web only. Let me ask you a question. Do you see any connection between this flange and this flange? Do you see any connection between this flange and this flange? No. The only connection between this web and this web. That makes sense? Guys, that makes sense? Are you with me? Believe me, I'm showing something very important, probably more important than what we cover in this course. So the concept is, if you would like to connect between two parts or two pieces of beams with a connection, this connection will transfer shear only. Shear means vertical forces only, without moment. You need to connect the two webs. Don't connect the top flange or the bottom flange. That makes sense. I understand this. We have here the connection. If you would like to understand what's going on, we have a steel plate. This steel plate will be connected by the right web by bolts, and the same plate connected to the left web by bolts from this side, and we have from the other side. No, we don't have plate on the other side. It's up to you. How much force, how much shear at this connection? you can define here the value of shear. If you have axial force, go ahead and define it. What is the lift beam? Go ahead and define the lift beam cross section. What is the lift beam? Let me. Because this is the lift beam. What is the cross section of the lift beam? Go ahead and select what is the cross section. For example, assume it's 18 times 60. Here you go. What is the cross section of the right part? Probably the same. 18 times 60, for example. That makes sense? Splice your blade. You can change what is the dimension of the blade. But because we have, it's a demo version, we don't have full access to everything. It's closed. You see, these numbers are gray with gray color, not black color. So we cannot change. But you can change what is the size of this plate. You can change what is the diameter of the bolts. In this case, it's a 3/4. Group A. The second bolts, 3/4 group A. Okay. You can open it from here or there. The diameter. How many rows do you have? It's 1 row. We can make it 2 rows. Can you see? 1, 2. How many bolts per row? 4 bolts. We can increase them to 6 bolts. Can you see? Change it to 5. 5 will be enough. Yeah. I'm talking about the left beam in your left. Okay, go ahead and close. What about the right beam? Diameter of the bolts, you can choose. We have 1/2, 5/8, 3/4, 7/8, 1 inch. How many rows? We can make 2 rows. How many bolts per rows? You can change it to be 5. So I changed the connection to be this number of bolts. Anybody can watch here what is the case or what is the status of the connection. Is it pass or fail? Pass means safe. This connection under the effect of shear force 60 kb and 0 axial force with this assembly of bolts, with this diameter of bolts and this number of bolts is safe. Let's see if we change 60 to be 100, for example. What will happen? Can you see here? What is the status of the connection? Failed. No, this connection is unsafe. So if we go back to 60, it's pass. That means it's safe. So what we learned today, until now, we learned that we have a connection called splice connection. This connection only, you can see here, different views from the top, isometric. These different views can give you everything about the connection. So we learned right now that we have a connection between 2 parts of the same beam. This connection in a structural analysis called pin connection will transfer only shear without moment. If you would like to transfer shear without moment, you need to connect only web. This web by this web. So we have shear only. You need to define how much shear do you have from structure analysis. How much shear at this point. Then you can try how many bolts for blade section. I think we have option here for blade section. Can you see? We have blade from one side. There is no blade on the other side. We have option here for blades. Where is the blade? Here is the blade section. Number of blade is single. If you choose it to double, what happened? I put blade on this side and another blade on the other side. So it's a double blade. We have this option here. So you can build your connection and put your internal forces from structure analysis, and you are watching what's going on with the connection. The final conclusion, this connection must base. Base means safe. Any question? Can we try here 100 one more time? It's still base. Wow. Few minutes ago 100 was unsafe. Yeah, because we have only one blade, but right now we have two blades. You know, if we go back to the blades and make it single, one blade only, it fails. The connection is not safe. So if you have this level of shear 100, we need to make this blade to be double, to be safe. So you are trying, you are doing many trials until you reach your connection is base and your applied load based on the structure analysis, then we are done. If you would like to get calculation sheet, we have here a report. Open it, you will give you a complete calculation about the connection. Here is the shape of the connection. What is the left beam? What is the right beam? What is the plate? What is the F yield, F ultimate? All of these calculations, and everything is base means safe. And if you would like to check, is it safe or more safe or more safe, go ahead and check this number. This number should be close to 1. This factor should be close to 1. 0.59, 0.88, 0.88, 0.7, 0.97. I believe you are good. You are good. You are good. That makes sense? Any question?
If the unity check, if it's further away from 1, is it more and more safe?
Yeah, yes, but remember, I don't care about 0.59. You cannot say it's more safe. No, but we have another case which is critical, 0.97. So at least one of these numbers should be very close to 1. That means you have an economic solution. Okay, if you try to change anything, okay, this number will be close to 1, but this one will be unsafe. We need to keep all of these numbers safe and the economy. So this one is 0.97 is safe, and the economy, which is the highest one, we are good. We are good. We cannot change anything anymore. Even if you have a number 0.59, I cannot change, because if I change something to satisfy this condition, this one will be unsafe. We have another question. Does the software give edge distance? And yes, can give you everything. For this plate, you should have here the thickness, the width, the depth of the plate. So if you have the dimension and you have number of balls and the spacing between balls, so you can figure out what is the spacing. And also for the report, you should have here a check on bearing, a check on shear, a check of group eccentricity, and a check also for spacing between the bolts, because spacing is a function of bearing on the bolts. So once you satisfy all of these conditions, you are good. Don't worry. So what you need, this beam is W18 times 60. This plate is with thickness 0.375 inch. The width is 12.125 inch. The depth is 15 inch. How many hole type? We have different type of holes, but it's not our problem right now. And you can check everything. So it looks like a game. Do you know there is a game Meccano for kids? So you are building few things, and the final shape you can check it. So we are right now trying to build our connection and put your axial force, shear force and the axial force from structural analysis. One of you will say, hey, where is the moment? We don't have moment, because at the first step you choose, we have shear connection. So we don't have moment. And then you are keeping your eye on what is the status of the connection. Is it pass or failed? We need this one to pass. And we need every of these numbers to be smaller than 1. Any question? I believe this software will be more interesting and you would love it. And if you're in your capstone project, if you have a part of your project related to steel, it will be better to use to design any connection using this software. Any other question? Oliver, did I answer your question? The software will check everything. We need only one word by the end: pass or failed. If it's still failed, you need to change something. Change what? You have different options. Change diameter of bolts. How many rows? How many bolts per row? What is the longitudinal spacing? What is the transverse spacing? Everything. You have many options. You need to change until you reach to base. Any other question? Okay. Anybody know what is the standard length of this beam? Did you go to a company or something like this? Do you have an idea what is the standard length from the manufacturer? Do you know what is the length of these beams? As I remember during my PhD, the standard length for these beams is 30 feet. Any manufacturer, any company producing these beams with this length. Actually, you can order any length you would like, 40, 50, 60, but let me assume the availability right now, we have this beam with this length 30 feet. So what is the problem? The problem, I would like to construct a beam simply supported with uniform distributed load. What is the problem? The problem is this bending moment has a length equal 50 feet. What is the issue? This beam has a shear, looks like this, shear force diagram. And this beam has a moment, looks like this. Yeah, I understand. What is the problem? I told you, the availability right now, we have this beam with 30 feet length only. And we need to construct a beam with 50 feet length. So what should I do? we need to make connection 30 feet plus another 20 feet. Okay, looks like your connection will be here. What is the problem? The problem is we have value of shear and we will have value of moment. So this connection of the two parts of the beam will support value of shear and the value of moment. That makes sense? That makes sense? Any question? So guys, if you are looking, we have part of the problem related to structure analysis. We have another part of the problem related to steel construction or steel design. Every issue in design, first you need to use a structure analysis. No way. Believe me, no way. Structure analysis is the basics. Anyway, so I will go back to the software. Please remember, if you have a connection to transfer shear only, I will connect this web by this web by this plate. Guys, I forget to show you something here. Probably no, it's not available here. Anyway, we can change rather than bolts to weld connection. I'm not sure. Yeah, here you go. Here is the one. The web connection is bolted. Probably you can change it to welded, bolted, or bolted, welded. Can you see? We will use one side is welded and the other one will be bolted. Do you know why? Because the one that the first part, this part will be fabricated in the shop, and the other one will be holed or drilled in the shop. In the site, we will construct just to connect the two parts. We don't have option on the site to weld both of them at the same time at height 20 or 30 feet. No way. So you can change the type. You can change the type. Bolted, welded from left, bolted on the right, or bolted on the left, welded on the right. If this is the case, so you can choose what is there. This is one for bolts, this one for welding, I believe. Here you go. Fillet size. What is the size of weld? And what is the type of weld? We have different type. Anyway, so you can change between bolted connection and welded connection. But believe me, for construction, one side will be welded, the other side will be bolted. The bolted will be fabricated on site. The welded will be fabricated in the company or at the manufacturer. Anyway, but your connection between web and web. Let's start another one. We have.
Okay.
Yes.
Just a quick question about the bolted and the welded connection. I've never seen anything like this. So I know if you had weld is stronger than bolts. But if you have both, would you say it's stronger than bolted, but a little bit weaker than welded?
Okay. Wait a second. If you have the two sides are welded, doesn't make any sense because we have a bridge and we will hold this part and hold the other part, and we will put the blade, and someone will come to weld weld, weld, weld. Do you think this process will be more easy or will be easy to do all of this stuff, holding this part of the beam and holding this part of the beam and holding both of them together, and someone will come wait for 1 hour or 2 hour welding around these plates and wait until the weld is good? Do you think is it possible to do all of this process on site? Yeah, if you can, okay, go ahead and do it. But remember, this bridge at height probably from the ground surface around 20 feet or 30 feet or 40 feet. So we need to keep all of this stuff together. But if this part of the beam on the ground is connected by this blade and welded on the ground, that's fine. And we have holes here, and the other part of the beam is held. In few seconds or few minutes, we can keep both of them together here and just put your bolts and tied them. That's all. Anyway, but for me, I believe all splice connection would be bolted from the two sides. I didn't see one side is welded and the other side is bolted. Both of them, most of the time, are bolted. More easy in construction, more easy for maintenance. If you would like to remove this blade, you can release these bolts and remove the blade and replace it. But if you have one side is bolted, is welded, no way. Anyway, so let's try the second one, because I have a key here you need to learn. So I will not use shear, I will use moment. Do you know why moment? As I told you, we need to make connection between two parts of the beam. At the connection, we have shear and we have moment. We have to choose moment connection. Okay, what is the type? Do you have beam column connection? No, it's not beam column. It's beam splice. Beam splice. Let's start with the first one. This one. Flange blades. Can you see? Wow. Wow. The first difference, this splice connection is a moment connection. How did you know this? Because the flange of this beam is connected to the flange of this beam by blade at the top and the bottom. Besides, this web is connected to this web by splice blade. So this connection is called moment connection. We can transfer moment. Besides, we can transfer shear. That makes sense? As I told you, if your connection is shear only, I will connect this web by this web, that's all. If your connection will transfer moment beside shear, no. In this case, this top flange must be connected by this top flange, and this bottom flange should be connected by this top bottom flange, and this web should connected by this web. In this case, your connection will transfer. Can you see? Shear, axial force, and the bending moment. Right now we are in connection number 2. Connection number 1, we are done with connection number 1. We are in connection number 2. Okay? It's a fail. Something wrong here. We need to change. Okay, go ahead and change. You have many options. Assume your shear is 60 and your moment is 60. Assume your loading is correct. So what should I do? Okay, let's start with blade If you choose anything, it will be in gray color. So you are right now, which one? In this one, this blade. And the plate moment, the top one, thickness, width, length, type of hole. Left beam, bolts. How many rows can you see? 1. If you change it to 2, we have 2. How many bolts per row? 4. You can change it to 5. Can you see? 5. If you are feeling it's you can return it to 4. That's fine. For right beam, number of rows, 2. This is still unsafe. Okay. Left beam, how many bolts there? Number of rows, 1 row. 2, but you are outside the flange. Doesn't make any sense. Keep it 1. Okay. What else? Spacing, longitudinal spacing, transverse spacing. You can change many things. You can do anything. If you have issue, doesn't save, you need to change the size of the beam itself. And also, I think you have here the connection. Is it bolted or welded? Is it bolted or welded? Is it bolted or welded? Sometimes we have weld on the one side and bolted on the other side. So you need to try until you reach the to be safe. Probably we can decrease this one. Still unsafe. Unsafe. So looks like if you go to here, which one is unsafe? Left flange weld limitations. We have geometric restriction, we have spacing between bolts, we have everything is good, but we have here left flange weld limitation. Left flange, this one, weld limitation, this weld is unsafe. So we need to change it. Probably this plate, the width is very huge. Probably we can change it to 7. Okay. What else? Plate, not this one. Moment plate, this one. The thickness, the width, probably we can increase the thickness to be 0.5 or thick. Anyway, right beam web. Here you go. Here is the fillet size in 16ths. 4 16ths means quarter. Probably quarter. Probably the thickness of this web is smaller than this quarter, the size. So probably you need to decrease this one to be 3/4, probably, or 2 16ths, 1/8. Anyway, so you can change. What is the problem? Trying to increase. I think the issue with this one, We can try this one. Yeah. Let's try 3. No way. Still unsafe. Looks like there is some limitation you didn't satisfy. You have to keep trying until you reach safety. The connection is safe against the applied shear and the applied moment. You have many options. You can change how many bolts, you can change the size of the weld, and keep in your mind this side of the weld. Can you see what is the meaning of 2? It's not 2 inch. No. Fillet size 16ths. That means this number 2 times 16ths. 1 divides 16. So it's 2 16ths. Okay. So, but we learned right now, if you would like to construct a connection to transfer moment, make sure you have to connect the top flange and the bottom flange. Guys, sometimes we have a column. And sometimes we have a beam. Based on the structure analysis, what do you like this connection to be? Do you like this beam looks like hinge support by the column? Or do you like this beam to be fixed by this column? Based on your structure analysis, you need to decide. If you would like to make it hinge, we have shear only, and the moment equals 0. We don't have moment. If you have fixed, we have shear and we have moment. So before starting to construct or to design this connection, you need to decide based on your structure analysis. So if you go back to the software, new project or new connection, if you go back to shear, beam, column, let's try. We have different technique. Let's start with this one. Can you see? Here is the column. Here is the beam. Here is the connection. We have angle. This angle, can you see this angle? This angle has 2 legs. The first leg is connected to the beam. The second leg is connected to the column. Do you think this connection is shear or moment? Any answer? If you are looking to this connection and you don't have any idea what's going on, what do you think? This connection is shear or moment connection? Do you think this connection is hinge connection or fixed connection? Any answer? Shear. Do you know why? Hinge. That's right. Do you know why? For one reason. You are connecting between the web of the beam by the column. Did you connect the top flange to the column? Did you connect the bottom flange to the column? No, we didn't. So this connection is shear. That makes sense? If you would like to connect beam column moment, okay, we will go down moment beam column. We can choose this one or this one. No, this one. Okay. Or yeah, this one will be good. Can you see this one? Yeah, this connection is fixed. This beam is fixed to this column. How did you know this? Because this connection will transfer shear and moment. Why? How did you know this connection will transfer moment? Because the top flange is connected to this column by this little plate. And the bottom flange is connected to this column by this little plate. And the web is connected to the column by this plate. So we have 3 parts connected to the column, this connection is called fixed connection. Does that make sense? By the way, we have different technique. This one is common. You have head plate. This head plate is welded to this beam at this top flange, and this web and this bottom flange. And the head beam is bolted to the column. So this connection is fixed connection. Do you know why? Because the top flange welded, the bottom flange welded, and the web welded. All of them welded to the head plate, and the head plate is connected to the column. So this connection is fixed connection. Any question? So whenever the flange of the beam are connected to the column, it can be assumed to be fixed. Perfect. Perfect. If you have cross section like this, your bending moment on the beam like this. Mainly, this moment is supported by the bottom flange in tension and the top flange in compression. So if you would like to transfer moment between this part and another part, like a column or another beam, you need to connect this flange and this flange to the other part. If you did this, we can transfer moment. If you didn't, we have only shear by this one. So this software is good. You can play the game and try to build many things. Here you go. For this one, for the head plate, you can change everything you need. For example, what is the width? What is the depth? For bolts, how many bolts do you need? What is the diameter? What is the cross section of the beam? What is the cross section of the column? What is the shear and the axial and the moment on the connection? So you can change what you want. Column bolt, how many? Let's try 6. But I think this is the pitch, spacing. Beam web, probably here. Column bolt, thickness. So anyway, you can find how can I change the number of bolts. Anyway, here you go. Bolt pattern, is it 4 bolts? Sometimes you have a huge amount of moments. You need a stiffener. Let's try. We can apply here a stiffener because we have a huge amount of moment. So we can apply more fixation between the top flange and the head plate, and the bottom flange and the head plate, to find something like this. Stiffener. Or number of bolts, 8 bolts, but without a stiffener. We don't need a stiffener. Or we can try this one, number of bolts. So you have different arrangement of the connection. You need to navigate between them until you found your connection to be safe. Guys, sometimes we have column base connection. Yeah, we understand for the frame that we learned last meeting, this frame is fixed with the ground. So the foundation will be footing, and here is the steel beam. Does that make sense? So how can I connect between the steel beam and the concrete footing? It's very simple. We have a steel plate. The column will be welded to the steel plate, and then the steel plate will be bolted to the concrete. One of you will say, hey, how can I construct these bolts to the concrete? It's called anchors. Before you pour concrete, here is the formwork of the concrete footing. I will put anchors with L shape like this. And this anchors is threaded at the top. Go ahead and pour your concrete. So we are pouring concrete right now. So this anchor is fixed inside concrete. And at the top, we have something threaded. Looks like bolt. Go ahead and put your plate, put your bolt, nuts and washers, and then get your column and weld it to the plate. That's all. So this one is anchor. This anchor inside concrete. Then I will put the head plate or the base. In this case, it will be called base plate. Bolt it by or fix it by these washers and nuts. Then get your column and weld it to the plate. This is the connection between the column and footing. In this case, it's safe. What is the axial force? And what is the bending moment, if you have? Sometimes this connection or this column is fixed. Sometimes it's a hinge. So sometimes we have moment. If you go back to the previous example I covered last meeting, you will find a moment on this fixed. If you define it as a hinge in RISA 2D, you will not find moment. Your moment equals 0, but you will find shear. So you have to decide what is the value of shear, what is the value of moment. Sometimes we have a connection here, brace to column base plate. Something like this. Wow, what's going on here? No, you learned this. Do you remember? Sometimes here is the elevation of your layout. Here is the main system, repeated. I'm drawing elevation. I told you in the first panel, we will construct here vertical bracing. Vertical bracing. Do you remember that? Can you see for this connection? We have a column, we have footing, and we have bracing. Here you go. This one. So the column is supported by the footing by this plate. The bracing is double angle, supported at this connection by this plate, which is welded to this column. Does that make sense? So if you navigate all of these types of connection, we have many. You can understand better how can we connect each part in a steel structure. That makes sense? You can change what you want, how many bolts, what is the size of this angle, what is the size of this column, what is the size of this footing, everything you need to change. You can change. After you are done, you can get a report and see what's safe and what's unsafe. If you are unsafe, your factor will be greater than 1. So what is the issue? The issue is with the gusset brace connection, bolt bearing on brace. We have issue with the bracing, with this one. You need to change the connection here, or how many bolts, or whatever the reason. So this software called RISA Connection, you can open and find RISA products. You remember where you download RISA 2D and RISA floor and RISA foundation? We have here RISA Connection. RISA Connection. You can download it and set up and run it as a demo version. And you can learn more and more and more.